Okay, so this lesson's on algebraic fractions and complex fractions. And more than anything, what I want you to get out of this lesson is that you need to be able to do fractions quickly. All right, this is me snapping my fingers. Quickly and without showing all the work that maybe in the past you have been showing. So there's a lot of examples, and I apologize if this is a long lesson. So for this first problem, I know that the denominator is going to be xy. So I'm going to write that down first. Now I just have to quickly figure out what the numerator is. And the fastest way that I know to do that is to multiply that together and get y, multiply the other one together and get x, and be done. Okay, so now let's try number 2. And this looks a little bit different, but I'm going to put this over 1 and know that my common denominator is going to be x. And I'm going to multiply this one together first and get x, and then subtract that one I multiplied together and get 1. All right, so down here, these denominators are completely different. So I'm going to have sine x times cosine x. And again, I'm going to do that cross multiplying thing. I'm just not going to write it down this time. The first diagonal that I'm seeing is cosine x. The other diagonal that I'm seeing is plus 2 sine x. Okay, so I'm actually encouraging you to try to do these without showing as much work as you always have in the past. So this denominator is going to be sine x. When I do the first diagonal, I get 6 sine x. Here's my subtraction sign. And when I multiply the other way, I get minus 3. Okay, number 5 over here. Okay, so multiplying by fractions. I know students find this very intimidating, but it really doesn't have to be. The top number means multiply, and the bottom number means divide. Okay, and you can do that in any order. So I want you to see that if I do 8 times 3 and then divide by 4, that I get 24 divided by 4, I get 6. And if I do it the other order, if I do 8 divided by 4 and then multiply by 3, that's 2 times, that's still 6. Okay, don't let the fractions throw you off. The top number means multiply and the bottom number means divide. So when I put those all together, doesn't matter which order you do it, the answer here is just 6 tangent x. Okay, now I love these. I know they look really complicated, and it doesn't have to be. Here's a really cool little trick. Denominators with other denominators can cancel out. So I can cancel that 3, and I can cancel out one of those x's. Okay, and the same thing is true for numerators. So this 4 and this 8, I can reduce that and get that to just be a 2. All right, and then the final thing to remember is that denominators that are in the denominator, like this, end up in the numerator. So this whole answer is x over 2. Now, I know that's a lot of information, okay? I'm going to say it again. Denominators with other denominators. You can reduce those, right? You can kind of cancel them, simplify them. And numerators with other numerators. Those can also be reduced. It makes numbers a heck of a lot smaller and easier to deal with. And then denominators in denominators actually end up in the numerator. Okay, these are all nice, really quick tricks that make this problem so much faster than the old way. Let me show you the old way you used to do this. Divided by 8 over 3x squared, and then you would have to change it to multiplication, right? And then you would reduce, but do you see this? Like, I'll even do it in pink because that's how I did it before. This cancels with this, and the 3 goes away. I did that before without having to flip everything over. I also canceled this 4 with this 8, making it a 2. All right, and when I multiplied what was left, I ended up with x over 2. But again, this is a lot of work when I can just kind of, and after a while with some practice, you'll be able to do these in your head without having to write all this stuff. So like this, let's take a look at this. Excuse me. This cosine is going to cancel with one of those cosines. This sine is going to cancel with one of those sines. And then this denominator that's in the denominator, right? It's a fraction within a fraction, ends up here in the numerator. This is cosine x over sine x, which is literally cotangent. All right, let's keep going. That was number 7. Where am I? Okay, here we go. Number 8. Okay, so for this one, and this is a little hard to tell, so I want to make sure I say it. This is the big fraction bar, okay? Which means this is the denominator that's in the denominator, okay? Now, think this through. If that denominator in the denominator is going to actually end up here, and I'm going to multiply it by that 5, can you envision in your head that you're going to get a 10, which is going to cancel with the 10 that's immediately below it, and my whole answer here is just rad 7. Okay, I love that. Okay, page 1, done. Let's see if I can get through these other ones. Okay, time for another shortcut. Okay, you know how, hopefully you remember this, when you used to, as a elementary school kid, you had that mixed number, and you wanted to change that into an improper fraction. You would do this number times that number, and then you would add that number, right? Which in this case would make 7, and you would put it over the denominator that you started with. Okay, so I would like to use that skill on this problem. So I'm going to start with the denominator. 6 times x is 6x, plus 1 more is 7x. And I'm putting that over the denominator I started with. Okay, now I'm going to do the same thing on this one. This is going to be 3 times x minus that x, so that's 2x over the denominator I started with. Okay, now think back, literally just a couple minutes ago, I taught you that numerators can cancel with numerators. That x and that x is gone. I also said that denominators could reduce with denominators. This is going to reduce with that. And then finally, I said that denominators in denominators end up in numerators. So this whole answer is 4/7. Just 4/7, okay? Without having to fraction bust, by just using some mathematical and algebraic skills, okay? So let's try the same thing on this one, okay? On the top and the bottom, when I make those into improper fractions, the top becomes 3x plus 1 over 3x. The denominator becomes 9x squared minus 1 over 9x. And then I'm going to simplify my denominators, meaning this x and this x are gone. That 3 and that 9 reduce, which puts this up into the numerator. So now my problem is looking more like this. 3 times 3x plus 1 over, and I'm going to factor that, 3x plus 1, 3x minus 1. Those cancel, and my whole answer here is 3 times 3x minus 1. Okay? Again, I'm trying to get you through this as quickly as I can. And hope maybe you're starting to see that once I know what these denominators are, right, I can start to simplify that quickly. Like before I even start, I know that that's going to reduce to just be a 3, and it ends up on the top. Again, start looking for some shortcuts. Play around with it. So like this one, I'm just looking at the denominators. This p along with this p to the 4th, I know that that's going to reduce to p to the 3rd in the denominator. So I'm going to put it up top right now. I'm just going to put it up there. And now I'm not even going to deal with the denominators. So next to this, p times 5p, that's 5p squared plus 1, right? Plus that 1. And down here, this p to the 4th times this 25, that's 25p to the 4th minus 1. something like that. Now this denominator does factor. And again, the goal here is to get you to be able to do these quickly. So just envision what this factors to be, and envision how it cancels with this one so that you can just write your final answer like this. I'm completely fine with that. I'm hoping that you can do question 11 as fast as that, right? There's not a whole lot of work to show. It's all mathematically sound, and it's going to save you a bunch of time. So let's try this one. Okay, so think about this. The denominator up top is going to be AB, and the denominator down below is going to be AB, right? I'm not even going to write that down. I know those are going to cancel out. So all I have to do now is figure out what those numerators are going to be. Up top, it's a squared minus b squared. And down below, it's a squared plus b squared. And even if I think about factoring the top, because it's the only one that factors, nothing's going to cancel. And that's my whole flippin' answer. So fast, so nice. Okay, let's take a look at 13. Okay, so I'm just looking at the denominators, and I can tell on the top, my denominator is going to be 2xy. And on the bottom, my denominator is going to be 2xy, which eventually are going to cancel each other out. So I'm not even going to write them. I'm only dealing with the numerators. Up top, this is 2y plus x. And on the bottom, this is 6y plus 3x. And this one does factor. The denominator factors. Now think about it. If I took out a 3, I'd be left with 2y plus x, which is going to cancel. This just becomes 1/3. All right, I know I'm not showing a lot of work. That's the point. That's the whole point. I need you to be able to factor in your head, visualize it, see what's going to cancel, and move on to one more step. This problem, getting to this, should take you 30 seconds tops. Okay, so let's see if I can get through this last one. All right. Okay, so I'm looking at the numerator and the denominator that's within the numerator. How about that? I'm looking at this and I'm looking at this. So when I try to simplify those two, I'm going to be left with just the y, and it's in the denominator of the denominator. That puts it up top. Okay, so now that I've dealt with those denominators, I only need to worry about the numerators. Right? The numerator, here's a 1. I'm not even going to write that. And the numerator down below is y squared plus x squared. All right. So about a 13.5-minute video. Hopefully that makes sense.